Welcome, makers, to a brief, highly selective, overly opinionated, vaguely chronologically correct timeline of 3D printing. Here we'll try to find out why it's called printing in the first place. Chiseling statues out of stone is certainly 3D manufacturing, but we tend to think of sculpture as an art form. Molding clay and pouring bronzes is another step along the 3D path, but how does that explain 3D printing? Well, consider that the Gutenberg printing press was introduced in about 1440, and by 1500, printing presses were estimated to have produced more than 20 million volumes. It's hard to envision the impact this had, probably most famously by making the Bible available to lay people and disrupting the power of organized religious organizations, but also by introducing mass communication and relatively unrestricted circulation of information, and at times revolutionary ideas that transcended borders. Printing led to a Western literacy culture, the ascent of universities, and new sociocultural stratifications, while bolstering the emerging middle class, and it enabled greater social fluidity. Later, the typewriter used similar, more granular technology of applying single characters to a tape of inked material, and that set free the thoughts of individuals in the privacy of their own homes. With that exciting historical base, our timeline will start around the 1960s, and here the Teletype Corporation introduces their inkjet technology. So we'll sort of take this as a point where the block or the key hitting the ink changes to a central ink source coming through a nozzle. Teletype used electricity to control the ink droplets coming from the nozzle, and they were quote unquote printed onto paper. In the early 1970s, Johannes Gottwald and Teletype patented the liquid metal recorder. So here they're experimenting with things other than ink being extruded through that nozzle, namely melted wax or liquid metal. So this is a thin thread towards 3D printing as we know it, but at the same time other technology was developing. Although the French were doing similar research at the same time, Hideo Kodama has been granted the title Father of 3D Printing for his work in the 1980s and developing the concept of layer by layer manufacturing. He used photosensitive resin, which was polymerized when exposed to UV light. So just a note, the internet was developing in the 60s and 70s, mostly connecting at first academic centers in the US. IBM was making huge computer systems for businesses, but Microsoft didn't really develop until 1980-82. Windows wasn't released until 1985, and so these folks were not working with tools as sophisticated as the most common software hobbyists have today. In 1984, Charles Hall is cited as inventing stereolithography. So this allowed for the digital representation of 3D models. Hall worked with, Kodama, he worked with photosensitive resins and released an SLA printer. That's a stereolithographic apparatus. And that was in 1988. So the STL files that we hobbyists use are a file format that's native to the CAD software created by Hall's company, 3D Systems. Carl Deckard patented his selective laser sintering process in 1988. With SLS printing, a powdered medium like metal is fused with a laser. Deckard developed his process during a summer internship at the University of Texas at Austin. And then in 1989, Scott Crump patented the squirting plastic through a nozzle technology that we all know and love. FDM, or fused deposition manufacturing, ended up being the technology that caught on for DIY printers, and we'll talk about that in a minute. Mr. Crump, but the company he started with his wife, Stratasys, remains a major player, sometimes the major player in the 3D game. It now owns MakerBot, and MakerBot's recently combined with the Dutch company Ultimaker. Many who see Stratasys as big squirting plastic through nozzle, are watching these combinations pretty carefully. Of note, in 1989 or so, the British scientist Tim Berners-Lee was working in Switzerland at CERN and created the hyperlink system known as the World Wide Web. So Berners-Lee's work remains a phenomenon of humankind. Imagine now researchers who sometimes do scientific studies or take observations globally or even across decades can collaborate. Researchers can quickly access reference documents, methods, and even data sets from decades ago. A sixth grader learning data analysis in Python can no doubt find Gregory Mendel's original pea plant data and do their own genetic analysis. That's pretty amazing. So that's setting the stage for moving on. So around 2005, Adrian Bauer, he's on faculty at the University of Bath in Great Britain, set forth his concept of the RepRap project. Bauer later relayed that the university where he worked acquired a grant to purchase a multi-million-dollar 3D manufacturing machine and a $50,000 FDM machine. He had had the concept of a machine that could reproduce replicas of itself since he was a kid. And he immediately saw FDM technology as the way to accomplish this, and he proposed this open source project to develop it. RepRap, short for Replicating Rapid Prototype. The patents from the 1980s were also falling into public domain, so the opportunity to develop companies around personal printers also opened up as well. So just to mention two other developments that are ongoing at the same time, CAD tools, or computer-aided design, is becoming a standard skill taught in both engineering and trade schools, as more and more people are developing the skills to create 3D objects from ideas inside their heads and manifest them in a three-dimensional space in software. There's more momentum developing to manifest those creations in physical 3 dimensions. And the skills for prototyping and iterating parts are also developing to move the RepRap project along. Another open source project at the time was creating a legion of novices working in programming electronic hardware. The Arduino project began with a group of educators creating a basic PCB to be an accessible development board for their design students. They also created and distributed for free software to make programming the board through a USB port simple and posted everything online in open source, which enabled a community who also iterated and shared to grow up around them, and that's the Arduino project. So the original RepRap model was named Darwin, and the process developed that someone would build the Darwin and then use it to print parts to send to someone else who wished to build a Darwin, and so on. In 2009, MakerBot is a company that was founded. It sold open-sourced kits to make FDM printers. But MakerBot also created Thingiverse in 2009. It's an online repository, so developers could post and share their modifications, their prints, their designs, and have an open forum to share ideas. In 2010, a Czech student began upgrading his build of the second RepRap iteration called the Mendel. Here's a picture of the Mendel RepRap machine. Joseph Prusa's upgrades became so widely adopted that the Prusa-Mendel model became a standard for RepRap. In 2011, the company Ultimaker was formed from members at a fab lab in the Netherlands. Ultimaker and other companies sought to build more reliable printers that function more like appliances for individuals or businesses rather than tinkerer kits. Around this time, the Marlin open source firmware was being developed within the RepRap community to service the electronic components of the printers and run the motion of the steppers and nozzle, etc. Multiple auspicious beginnings happened in 2012. David Brum created the slicer software Cura, which takes the stereolithography files that we talked about with Hall's company, converts them to G code for printers firmware, Marlin, which we just discussed. So Cura was set free to the world, and also a small makerspace was begun in Decatur, Georgia, called Decatur Makers, and Decatur Makers held an open build event to put together a kit printer from Lulzbot. Also this year, the Prusa brothers founded Prusa Research and began developing a printer farm to create Prusa printers on a large scale, and a German programmer, Gina Huska, created software that allowed her to control her printer via the USB port on her computer, which she called Octoprint. Octoprint was also developed for the single board Raspberry Pi computer and was called Octopi. This allows the Pi to control the printer, and the owner then can access the Pi via Wi-Fi anywhere in their home or even outside of their home. This way, the printer can be in a separate room for reasons of space, noise, or ventilation control. By 2014, the i3 design, popularized by the Prusa Mendel, had been pretty much optimized for price and reliability, and around this time, the Chinese company Creality was established. Able to source parts inexpensively and produce kits in volume, Creality's flagship Ender 3 became very accessible to DIY hobbyists all over the world. Let's not forget the development, the open sourcing, the passion that got 3D printing to this level, but now someone could just go to Walmart, buy a kit, and go home and build it for a reasonable price. Around this time, David Braun was also employed by Ultimaker, and Ultimaker provided Ultimaker Cura, the slicer software, free for anyone to download, and that kind of made it a popular choice among hobbyists. The next few years saw multiple Chinese companies selling machines at a very low price point, and also saw some early companies struggling to survive. Remember, 3D printing is a truly global initiative, so Ultimaker in the Netherlands, Prusa in the Czech Republic, countless designers and developers in Australia, Great Britain, the US, Octoprint in Germany, and printers continued to land in all the maker spaces being funded in schools and libraries and man caves. And more recently, Clipper software was developed, which takes advantage of the proliferation of inexpensive single-board computers like the Raspberry Pi. The Pi, with its additional computing power, does all of the G-code processing and computing of the printer's movements, and then sends that information to the mainboard, which then only has to interface with the hardware. The higher-level calculations and processing enables faster and more precise movement of the nozzle. The design with the bed moving back and forth, or to and from, forward and backward on the y-axis, is sort of recognized as a liability. It causes some movement of the part and also creates a larger footprint. So more printers are being designed to move the bed only up and down on the z-axis. Then non-intuitively, the core XY design moves a very light nozzle with a more complex belt configuration, but this allows the stepper motors to be stationary and results in printing up to 10 times as fast. Then in 2022, Bamboo Lab offered their X1 3D printer that has AI capabilities. And at the making of this video, 2023 has a lot on the horizon. 3D printer technology on the shoulders of all these creators is being used to build houses. It's used in medicine to extrude collagen and grow cells. It's being used in fashion, in clothing, sports. It's used in space. It's used to print chocolate and to create models in surgery, from CT scans and MRIs to plan procedures. It's used in prosthetic hands and facial prostheses. It's used for assistive technology for people with disabilities. And it was used during the COVID pandemic for the local regional provision of PPE. The agency that comes from manipulating objects in three-dimensional space in CAD programs is really hard to quantitate. It's all that to say that the struggle to get a little benchy or a carabiner or a whistle to print on a hobby printer is an important investment in building the skills to work with 3D printing across multiple industries. So insert your photo here. Be the printer. And thanks for watching.